and animals have been hurt in our study. So yeah, I'm presenting a pilot project that we conducted a little bit earlier this year, and where we explored augmented reality for mineralogy exploration, and specifically using hyperspectral imaging. For those of you who don't know, hyperspectral imaging is basically a technique that allows you to capture spectral information for each pixel in the scene that goes well beyond the visible light spectrum or the visible spectrum that we capture with a normal photographic camera. And that basically allows you to classify what you see in the scene. And we're looking specifically at the geosciences context, where it allows you to classify different mineral deposits that you measure with your hyperspectral image. Typically those measurements are done in the field, and then an analysis is done offsite, back in the office or where else. And what we propose is to do situated mineralogy exploration using augmented reality. So we did a use case analysis with a couple of geoscientists in our organization who basically came up with 4 main use cases where I think something like this would be really valuable. The first one I already sort of alluded on would be geoscientists in the wild, where you basically can go out into the field and have your headset on, and you basically can explore the mineralogy of rock surfaces, and that would allow for more effective path planning, site selection, and mineralogy analysis. Another use case would be in the mining sector, where it would basically enable mine site operators to distinguish ore from waste. So typically that is done more in an offline kind of way as well, where you basically take samples and then there's someone analyzing what's ore, what's waste, and then they plan the mining operations. And if you were to be able to do that in more real-time or near real-time, that would be highly valuable in the mining sector. Another application would be in drill core exploration. So there's large physical drill core libraries, but also very large virtual libraries where there's a lot of different drill cores, and being able to connect physical libraries with virtual libraries through an augmented reality interface is a very valuable application as well that they see. And last but not least, also sort of for outreach and education purposes. So basically to engage students and pupils in geosciences by having such immersive, engaging interfaces. We came up with a couple of user requirements that informed our system design, and I will just quickly go through them. So the first one is basically the situatedness. That would be very valuable to be able to do this analysis in the real-world context. It's important that the hyperspectral overlay is directly embedded with the physical referent, but the geoscientists also said that would be very valuable to have additional line spectra available. So what you embed is basically just a classification of the mineralogy, but additional line spectra that show you the full information for each of the pixels in the scene would also be valuable. Mobility is a very important aspect, and also the fact that you want to have your hands available to do your actual science, which is one reason why we decided for a head-mounted display rather than a tablet kind of application. And then also visualization of other interpretations that can be derived from the measurement data would be eventually useful. So we actually used a art piece in our center for prototype implementation. It's called the Daedalus Wing. It contains 29 different minerals from across Western Australia, and we used that as a use case for designing a prototype feedback. So everyone found it to be a very engaging experience and likely to be useful once it's actually deployable. So at the moment the HoloLens doesn't lend itself to be actually deployable in the field, but also as I mentioned, we don't have the actual hyperspectral images in there yet. Typically gestures and clicker were preferred over voice control, which we found interesting. The field of view was too limited for many people, so even though people were standing quite far away, since the art piece is quite big, it's probably also quite representative of a real-world scenario if you have a large rock surface, but that will probably be overcome with new iterations of AR interface and the HoloLens 2 or so on. Sunlight interfered quite a bit, so whenever the sun came in the afternoon, people found that it was interfering with the experience. And quite a few people actually mentioned that multiple interfaces for collaboration would be really interesting, because they try to sort of tell each other what they can see, but then obviously if you can't see what the only person who's wearing the HoloLens is seeing, then that's not overly useful. So yeah, what we presented was basically a HypAR prototype design and implementation. At the moment we already use it quite a lot for customer engagement as well as for outreach and education, so we actually go to science fair with that and use it for that purpose already. So we are looking into integrating hyperspectral imaging data once we have a camera available. We're also looking at building this collaboration interface, and And once the HoloLens 2 comes out, it should be quite easily ported, and then we should overcome issues like with the visual field. That's it from my end. Thank you.